And now Shant will present how it works from inside. Thanks, Shant, please.
Hello? Yeah. Hello. Thank you so much, Rand, for a nice introduction. And that's my pleasure and honor being here, guys. So today, yes, we will discuss about our publications and also what's behind them. And of course, about the products, because Picsart's main goal is the business and our product. And all the publications and papers are motivated by the product we are developing. Yeah, so the overview of today's talk will be like a quick introduction and the learnings from the scientific innovations and learnings from building product. So you can notice that I'm avoiding saying publications because the most important thing here is not publishing papers but getting scientific innovations. That's why I wrote here learnings from scientific innovations. And a couple of words about me. I'm a staff ML scientist in Picsart and also leading a group of scientists. And also I'm giving lectures in Yerevan State University. Here is my LinkedIn profile, so if you will have any questions or if you just want to connect and say hi, just, yeah, please feel free to connect. Yeah, so about the AI products, what we develop in the team. So here are a part of our products. First of all, remove background, which is when you have an image, basically it is a segmentation problem for every pixel in the image you want to segment, classify between two classes, foreground or background. This one is quite useful for the users because sometimes when you take a photo of your product and want to, for example, sell it, you just remove the background and put something more interesting, like more colors or like a plain background, etc. So we were developing this for, I guess, for already five or 6 years and giving versions. And for just a comparison, here when I was making these slides, I was also trying to the same feature with the Google Slides. So with the Google, so this is the result of them. I don't know, maybe with Nano Banana, of course, they will have something much better than this, but this is what they have still in the Google Slides. Then, after the remove background, the video person segmentation comes with such effects that can be applied on the background and foreground. And of course, it is also present in Picsart, so you can download and try. And then another big scope of projects is the projects about the image in painting, when you have an image and you want to edit the image based on the content. For example, you want to remove something or generate something based on the prompt. For example, here we have the user masked this region and wrote teddy bear, and the teddy bear is generated. Another one is smart background. When imagine you have an image, an object, and you want to change the background with the prompt you write. Or AI expand, when you want to just extend the content of the image and yes, without zooming out. Also, we used to work on video generation. I will talk about that a bit later, but as an example of our product, we used it as a GIF generator. I guess it was 2 years ago when such small GIFs were still being useful for our users before all this AI video generation hype we see today. So basically, that's it, what I wanted to say about our products. And yeah, now about the scientific contributions and innovations we try to have. We started in 2020, and until now we have 23 publications with total almost 1,000 citations in top conferences, in CVPR, ICCV, NeurIPS, ICLR, etc. So for example, this year we were in CVPR presenting one of our works I will show shortly, and also we were presenting in ICLR another work which was the basis of our AI replace AI background and in painting products now. Yeah. So now let us start to talk about the learnings from scientific innovations, how we do that, and what path we go for such innovation. So the first of all, topic selection. Every research path includes the topic selection. In our case, this is motivated by the company. So we have some products, and based on the products, we are building our research around them. And then when the topic is already selected, then we do the literature review. After that, problem analysis of existing solutions, because of course, if a product is famous, then a lot of solutions exist. For example, in the case of object removal, when you have an image and you want to remove some redundant objects from the image, of course, this was a very famous topic, so many people were working on that, and we're having lots of problems with the results and their methods. And then after finding the main issues with the existing solutions, then we brainstorm and understand how we can improve on these solutions. And we start experiments. And of course, here we have iterations, like having some experiments, failing, refining the experiments, and iterating until we'll get something meaningful. And of course, after that, the small part, I'm saying small part because for the scientific innovation, this becomes small, but if you strive for a publication, this is actually the biggest part, the writing. And after that, we formulate the results and write the paper, or at least the draft. So here I'm showing one of our papers, which was actually the first one. That's why I wanted to share and show how we started the journey. And it was accepted in ACCV 2020 and actually got the Best Student Paper Award back at that time. So the topic was driven by the company, of course. We wanted to do the imaging painting, which back at that time was meaning not the painting what means today, but it was it meant removing objects from the images. And we noticed that the solutions back at that time were deep learning based solutions, of course, and they were lacking the quality in terms of having fine details, because the deep learning methods like neural networks were convolutional based, and the convolutions are kind of you can imagine they are like averaging with some weights. They are averaging the tensors, the matrices. So maybe partially according to this reason, we were having blurry results based on pure deep learning methods. That's why we were designing another approach, which was mixing the deep learning and image processing approaches, when we knew that we should somehow force the neural network to be conditioned on some input, which was including the known region pixels in the unknown region. So here we were computing some similarities, and based on similarities, we were filling the region, and only after that we were applying the neural network parts. Like this was being done inside the network, in the convolutional layers. So that was the idea. And then, of course, we were doing lots of experiments, putting the module in different places in the neural networks, trying to understand how we should change the module we initially had an idea about. And it took approximately like from 3 to 4 or 5 months until we had a significant result, which we assumed that deserves to be submitted somewhere, and we submitted, and yes, it got accepted. So that was an example of this journey, and of course, it also included the writing of the paper. Another example I want to give is a work was done 2 years ago and actually has had a high impact, more than 680 citations. That was in Paris in 2023 in ICCV. And back at that time, the video generation was not so popular as now and was not so developed. So methods generating just such small GIFs, and also methods somehow transferring the style was quite interesting for the community. And yes, this work also was done as a scientific innovation, and it got accepted to ICCV 23. One thing I wanted to mention, one important learning we had from this paper was that whatever we mention, whatever we say, we should describe it in a very clear way. I know this might sound like very simple and intuitive, but sometimes you try to write, or people try to write a lot of things without paying attention on simplicity and and clarity. So this one is the key thing to be done in the paper. If you want to publish the paper, of course you should have a very good writing of that, and everything should be clear, because people tend to reject what they don't understand. If I don't, even as a reviewer, if I don't understand something, I feel more secure to reject that than to accept the paper. Of course, the best thing is to try to understand whatever they wrote, even if the writing is very bad. As a good reviewer, you should go and try to understand everything, whatever they write, and do your best. But, you know, nowadays the reviewers aren't the best ones, and they will just reject, or maybe they will just review with LLMs, which will not understand what you write. Yeah. So this one, I just wanted to share what we have had this year in CVPR. This is the development of the previous project, when we already were able to get such an improvement on video generation. So all these videos were generated from the text prompts, similar to the previous one, but here we have more smooth motion, and yeah, just wanted to mention that this one is the next stage for the previous one. And coming back to Singapore ICLR 25 and sharing with you one of our important papers, which actually became a basis of one of our main products, imaging painting. When you have an image, you mark a region and then write a prompt and generate something in that prompt. An important learning from this paper was that more contributions doesn't mean higher acceptance chance. So guys, actually, when we were writing this, we had a couple of contributions, and actually 3 major things. We introduced 2 major blocks. One major block and the other was a sampling algorithm. And also we made everything on higher resolution. That's why it is called HD Painter. And all these 3 contributions actually were too much for the reviewers to review carefully. So they were asking lots of questions about the contributions. Basically, more contributions are not increasing your chance, but they are raising more questions. So try to raise fewer questions to answer. Of course, it turned out that this paper would be easier for us to publish if we just divide it into 2 papers and write 2 of them, and we would have 2 publications. But yeah, we just wanted to go with this, so it got accepted in 2025 instead of being accepted in 2024 in the same conference. Another one is about the same task, imaging painting, when we want to remove objects, but I share this result to show this learning when I say don't chase cool ideas, just try for the impact, because and try the easiest ideas first. Because as you can see from the title of this paper, we write a simple baseline for imaging painting, or there are lots of papers named a simple baseline about something. And the idea is not to get something very complicated or sophisticated. The idea is to get something which really works and really has some impact. And here you can see how impactful it was in comparison with the mobile methods back at that time. So we were better than Samsung Galaxy S22 or Huawei or even Google Pixel 6. Yes, our method was working on mobile devices. I didn't present the numbers, how fast it was, so you can go and read in the paper, but it was quite fast and acceptable for mobile devices. And yes, again, here the impact is don't chase the cool ideas. Couple of failure cases. Basically, this was a theorem, we proved this year about the diffusion models, which was allowing to somehow use one diffusion model, pre-trained diffusion model for a setting, for another one setting. Like you have this theorem allows a transition between two score functions when you have two settings, two noising schedules for diffusion models. But it turned out that this theorem is not, it's not so easy to use in a straightforward manner. And basically, yes, we decided not to continue in this direction. We have a nice theorem, but it didn't work in the practice. I'm not saying that it will not work, because in one of the papers from NVIDIA, which was called SANA, and then they developed SANA 1.5, SANA 2, etc. In SANA, they used something similar. They didn't formulate this as a theorem, but they were just using it for particular two types of diffusion models. Of course, this is a general version of that. But yeah, again, in our setting, this one did not have enough impact to put more effort on this and continue. Yeah, and the learning from this one was, don't expect the theory always work, and always do quick experiments and reject ideas if they do not have enough impact. And again, if we strive for publication, we might think about continuing that, but basically we are thinking that the impact will be not much. Another failure case was when we just started the diffusion models. I noticed that for low values of noise, predicting the noise from the noisy version of the image is quite easy, because the noise amount is quite low. And for very high values of noise, the prediction of the noise is impossible, because if you have a pure Gaussian noise, you cannot predict the signal behind. And that's why, but back at that time, this lambda function in the loss, in the objective, where people were taking just constantly 1, and it meant that we treat all the noise values equivalently. And what we decided to do is to somehow change this weighting function to be dependent on this signal-to-noise ratio, or dependent on the input images or input noises. So we failed to do that. Because the idea was somehow clear, but the implementation was not as good as it should have to be. After some time, I have noticed this approach, and also a couple of methods appear which were having the same idea, and they were implementing that correctly, and eventually they have got whatever we wanted to get. But yeah, that's the research, and they had the way to do that. So good ideas always require good implementations, and this is not the only case we had. When we have an idea, our implementation was not so good, and then after some time we found out that other people implemented the same idea in a better way. So here is a small notice. So guys, when I'm saying implementation, I don't mean the coding. I mean how we can actually formulate the clear algorithm, the exact strict algorithm based on the idea. Because here what I presented, this is just an idea, and the algorithm, exact algorithm, was different between us and them. So when saying implementation, don't understand coding, but understand getting the strict formulation of the algorithm based on the idea. Couple of words about the product. So yes, now about the learnings from the product. The development product research lifecycle is the following, just quickly going over them. Always we have an idea formulation. Usually we have it already from the company. They are showing they are doing product market research and then formulate their requirements. And after that, we start the R&D. We do experiments, we iterate, we see what's the problem and make some improvements. After improvements, when we already think that we have an improvement, we check the results. We do user studies, asking people to vote, and also asking our product managers to validate that this is what they and us were expecting from the new version. And then choosing the best model among different versions, and then going to the service deployment for real users. After that, we analyze the real live data. For example, it turns out that we are doing A/B testing and A/B was lost, and our new model, which we were expecting to be better, actually is not the good one. And about that I will talk a bit later. And of course, the important thing is how to prioritize the problems for the next version, because a model may have lots of different problems. For example, in the case of remove background, you can remove the background of an image, and after that you can notice that some leftovers are left in the image. This is one problem. Another problem is that you can see that some holes are present inside the foreground object, like false positives and false negatives. And both are problems. Or edges are not as you expect. They are coarse edges, and you want to refine them. So problems are in different types. So we need to somehow prioritize the problems we want to solve first. And the idea is to prioritize the problems which are happening more often with the users, and basically with the users who are paying, because the problems which are happening with the users who are not paying, from the business perspective, may not be so important. Yeah. Again, a couple of words about the products. The main challenge for this in painting stuff was the memory and speed, latency on high resolution, and of course the user problems, real problems we had, like the blurry issue, etc. And the learning from here is that good and impactful research paper doesn't mean good product. So there should be a lot of things done to make a good paper, accepted paper, and a paper with very, very nice ideas, etc., to make it really work for our users. And this is also a very important part, maybe the most important part of the research scientists. And maybe not so visible as publishing papers, but still it's much more important than any publication. Another one is the remove background, as I already said. And the learning here was that sometimes we may have better models which may lose the A/B testing, and the problem, the issue may be, like, for example, the wrong prioritization of problems. We were thinking that this problem is frequent among the users, but it was not. Or maybe there were some deployment issues. For example, there was an error rate increase for some reasons we don't know, etc. Basically, that's it. And the key takeaways from this talk are perhaps in these two groups. First of all, about the scientific innovations. Don't chase acceptance, but chase impact, because impactful papers eventually will get recognized. Yes, nowadays, personally for me, acceptance means nothing if there will not be any impact of the paper on the research community or on our business. Keep it simple and clear. As I said, people tend to reject whatever they don't understand. And yes, for product, good research is not always about good products. So you should do a lot to make it a good product. And again, don't chase cool ideas. Strive for impact for the business. So for the business, you can do something very simple, which you will think that this worth nothing, but actually this worth a lot when it makes an impact on the business. And yes, of course, find the real problem of the users, even if you think you already know, but try to validate as much as you can. Yeah, that's it. Thank you.
Can you go back to the previous slide?
Of course.
Yeah. So thanks a lot. Actually, this is pretty interesting. So you mentioned that there have been cases where your new algorithm that you wrote is better according to your benchmarks, but then you put it on A/B testing in the product and people don't like it. Does it mean that the benchmarks are
Of course it means. Yes, of course. So eventually, okay, we can assume that the A/B testing method is not correct, but it's like more
That's what we
likely that the
care.
benchmark is not correct. So the benchmark for image processing or computer vision is not as representative as, for example, in the case of a simple classification where we chase to increase the accuracy. And here everything is about the visual stuff. And sometimes when we say benchmarks, we also mean like user study. We give the people the options and they choose. And sometimes our method is even significantly better according to the tests that we collected and the people we have chosen for the voting. Of course, we cannot choose all the users for this user study. And yes, it turns out that something is wrong there, and it is extremely difficult to find out what's was the issue in this whole process. And we just keep improving and keep looking at the user feedbacks. Like for example, did they subscribe after using, or did they cancel the result, etc.
That's interesting. So I had a hope that maybe in those cases you can figure out what is the reason, like what people are liking, right? But probably it's hard.
Even if we ask them questions, we also tried that. Like we asked them questions. What's wrong with this image? And I think you will never guess what was the first answer. Yeah, sometimes they did like, but they just didn't want to buy the subscription.
Okay.
That was the reason. And the next problem with the users was that they did not understand what's wrong. Sometimes they did not understand what the tool was about. That's a product issue, so the product should solve that, should somehow educate the users for what they can use this or that tool. Yeah, and there were a small amount of users, a very small amount, which were giving a constructive feedback about what can be improved. And we should work on that and understand how we can incorporate that information into our understanding.
Thank you for the talk. I'm interested that since you're doing the research in the company, do you consider patenting some parts of the algorithm that you publish, of the system that you publish?
Yes, of course we do. Thank you for the question. And actually we have already 2 patents. One is about a paper I didn't mention. It's also about imaging painting. Back in 2022, I guess, we had a paper in WACV, which was about mixing some Fourier transformation blocks with the deep learning methods and doing and generative adversarial networks and for doing imaging painting. We patented that one, and also after that we patented the work, this text-to-video work, this one, yeah, we patented this one, and yeah, we're considering patenting, and these 2 cases were so far, yeah.
One? Okay. Thanks. Just wanted to ask, do you have somebody responsible for keeping the alignment between what you research and maybe consider for what's going to the product? So do you have a dedicated person who says, guys, don't research
Don't
that,
publish this, or even don't research that?
Don't research that. Or says, research this, please.
Okay, so basically, I can say yes, but the responsibility of that person is not only that. So the person is my manager, and whenever we want to publish something, of course, I ask them, the manager and the CTO, to make sure that they are okay with that. It was, so it is about all the publications, so we make sure that everyone is okay, but usually, yes, that's if we decide to do a publication, then if we go to them, it means that most probably they will say yes, because of course we understand that the methods, which include something important for the company and could be used for as a competitive advantage by our competitors, we just do not even try to publish.